Okay, so for the octagonal clock question I gave you, so figure 5, I will do both, don't worry. What you'd look at is that on the left hand side you're given the elevation, on the right hand side you're given the end view. So left hand side is going to be the elevation, EL. Alright, on this side is going to be the end view, EV. Right, that's the first thing you need to look at. Second thing you look at is, right, how do I draw this? So they've told you that the overall size of this is 85. Now, for the size of the sheet that I have, guys, I'm going to scale this down to about half. So 42.5 is what I'm going to do here. Okay, so 42.5. Actually, now I'll keep it big. 85 we'll go with. Right. It's going to be a bit massive, but oh well. Right. So this one, extend this up to 85 as well. And go across the top and up here as well. Right. So you have been told that you have a octagon that fits into that box there, and you're going to have to be able to draw a 3D view of it in a second. Issue, how do you draw the octagon? Now, if you're ever faced with this, and it's one that caught you out in an exam, I've had a catch out leaving certs and everything else. If you're given a shape like that, break it down. An octagon has 8 sides. So it's 360 degrees, which is the 100 degrees in any object with 4 sides or more, divided by 8 equals 45. Okay? Don't believe me, if you divided that by 5, you get 60 degrees. Or, sorry, 72 degrees for the pentagon. You get 60 degrees for a hexagon if you divide it by 6. Okay? So whatever amount of sides your object has, or is meant to have, divide that into 360, you get 45. Likewise, if you're just doing a square, 360 divided by 4 is 90. Okay. Right, what do we have then? We have, how do you draw octagon, knowing this information? If we look back at the basic geometries, there's numbers of ways of doing this. Alright, but this is the one I like to do. So I can connect the two centers, because the center point of the square and another square is going to be the same. Right, so connect my centers. What I'm going to do then is I am going to open my compass out to the diameter here of one of these sides. Push you over a little bit so you can see what I'm doing. Okay. Make sure it's exact. And then one construction circle around it, all the way around. Excuse me. Including all of these points. How does that help me? It doesn't really. What you can do, you go horizontally across, out past the two sides, and vertically up, out past the two sides. And what you have when you have octagons is it's basically one square, shrank, turned sideways, and sits into the other. And what I mean by that is, if I go to draw my octagon now, if I go from this point here, which is one of those construction points I just drew in, to this point, and I connect those, I'll actually get an edge that is 45 degrees here and at the right place for an octagon. Same thing down here. I have this point here and I have this point here. I can draw those. And same thing up here. Okay, so the thing with this, they rarely put how do you draw an octagon onto a hard level paper. Right, I kind of expect you to know this shit, or this stuff. Right, what you need is, you need to know how to do it when it gets into questions, bigger questions. Okay, you need to know what's the word I'm looking for? The systems behind it. That's the word. And you can finish in your octagon like that then. Right, you need to know all the strategies for this. Right, so you have your octagon drawn there. Important to note as well is that you now have your heights that you'll need here, here, and here for drawing your end elevation over here. Right, They've told you that the entire width of that is going to be 82. So 82 millimeters, good to hear. Okay. They told you it inclines back at 60 degrees. Just have to move this so that you'll fit. From that point, it goes back at 60 degrees. And where you get your height is over here, so it's actually 85 high. Okay, mark off that point. 85. And as I said to you, you're going to get your other heights from over here as well. So there's one height there. Mark that off. Another height here. You can mark that off. Now what you do is you go parallel to the base for each of those. So that one there. That one there. And we have our top point here as well. And just carry this up. Right. Quite quick enough to draw. For the axonometric now. Bring all of these into one central area here to get your 3D view. I'm going to bring down my base first of all. So bring down my base here. Okay, and the important thing to look at for the base is that there's only two lines on it. You would have this one coming out and this ground as well coming out. Okay, so we have this section here is on the floor. I'm going to work up in lines and just put these ones in there. It's stepped like this, easier to work up lines. So I'm going to bring these ones in next. So what I do, go to the front of it, bring that line in, bring this line in. A little bit further maybe. Okay. Got my sheets. Now with the angles we were given, we're coming in, so this is going to be 1. This is going to be 2. Just double check it. Okay. Slide back out. You're going to have this point here. And you won't see the back point, so don't worry about that. Okay, you won't see this point here. What I can look at now is I can look at joining up some of these just so that makes a little bit of sense. So that'll join up to there. And this point here will join up to there. Now remember, this one's going to look a lot longer on the front than it does on the back because it's a cut surface and it'll be sloped away from you. Okay. I have this one here. And that'll join up to that point there. Alright, next line up. Bring this in. Bring the back of it in. Okay. Bring this along and stop it where it needs to stop and just mark it off there. Mark it off here. Same with this one. I'm going to bring this in. And I'm just going to stop on the front side as well. I'm going to mark off the back, but I don't think you'll actually be able to see it. Okay, so this matches up to here now. This point here matches up to the front edge. They go along the same line. The back edge joins up, and this will probably go straight up all the way. I'm just going to bring up that little bit for the time being. And the reason for that is a straight cut to the back, sloped cut to the front. So that's why this looks so big in comparison. Okay. So we have those. And we have this point here as well. We brought that in, yeah. Okay, last one, we're going to bring in the top points. Bring those up. Okay. And sliding set squares, set them up. Bring in those top points to where they're going to hit. So they're going to hit this line here and this line here, the upper one. And at the back, it's going to hit those same two lines just a bit further back. And make sure you bring in your construction line. Okay, they'll join straight. That will join straight. This line and this line will connect together. So will this one and this one. Okay. We have our octagon coming out here. So that's going to slope back in again. This will slope back in. And we have this straight edge here. Okay, so remember there was the edge underneath here. That came up to this straight edge. That should be fairly perpendicular. Might be off a little bit. Just with my sheet moving around. Right, that even realistically should be a lot straighter. I brought one of those in incorrectly. So that should be a straight up line. It's straight here. Okay. Then that would join back. And there we go. Just gonna have a look here. Yeah. So you can see my accuracy went off coming in on this line. You can see how this one gets narrower. I'll bring it in a little bit closer there. Alright, you can see this line here and this line here aren't quite parallel. So that would actually be joining back to here. Okay. And that's that question done.